So yes, I'll start off explaining the difference between the two power detectors that Guerrilla RF offers, the GRF1201 and the 1202. The main differences between the two is the power range that they can detect at. The 1201 works from around 0 to 20 dBm, whereas the 1202 operates around -60 to +5 dBm. So you have, different ranges depending on the application. Also, you can use various voltages from 3.3 volts to 6 volts. There's two tuning handles on this part to help with the dynamic range over frequency and voltage. One being the V-enable resistor. You can adjust that for various voltages. And the other being the input series capacitor. You can go smaller with it for high frequencies and bigger with it for lower frequencies. So what are the common questions that customers have on the 1202? Probably one of the most frequent ones I get is why at the lower voltages do you lose some dynamic range, some detectability range? And again, this is due to one of the two tuning handles I mentioned before, the V-enable resistor at lower voltages. So this was recently a customer example. They wanted to actually operate even lower than 3.3 volts at 3 volts, but you can see how at the lower power range it flattens out. So this isn't usable at very low power. But again, once that enable resistor is adjusted, then you have a usable, nice linear curve for detecting power. So how does it behave over frequency? With the standard tune, it handles pretty well around 700 megahertz to 6 gig. If you want to go beyond 6 gig, I've gone up to 8. You just have to lower that input capacitor from 100 picofarad to roughly 2 picofarad. And then vice versa, if you want to go all the way down to 400 megahertz, you tend to just go a little bigger with that cap in order to get a wider frequency range. So the dynamic range stays pretty constant over frequency. It's actually one of the good things about it. They line up pretty well with each other and I don't think the dynamic range really changes over frequency. Now the voltage level changes, but not so much the dynamic range. I also have some plots for that. So I have different plots for different voltage levels. And on the right, you have the key for frequency differences between 700 megahertz and 6 gig. And if you pay attention as I scroll through, this is starting at 3.3 volts and moving up in voltage. You can see the y-axis voltage range changes. So there's 4 volts, there's 5 volts, 6 volts. So the actual dynamic range, the slope of the curves do not change, but the voltage detectability does. So what else I think is interesting is about the 1202 is that it is really broadband. Most power detectors, when you look out at our competitors, are a little more narrow band and meant for specific cellular bands. And this handles a pretty broad tune. So that's what interests me most about this. In the future, we're considering other power detectors for narrowband performance, but this one is a really good general detector for most frequency ranges. Where would a customer want to use the 1201 over the 1202? Basically, that comes to the power range that their application is going to be operating at. Anything above 0 dBm, you'd want to go with the 1201. Anything below 0 dBm, you'd want to go with the 1202. It's pretty much as simple as that. This is a log detector. Overmodulation, we saw no differences in performance and power detection. We measured at 10, 20, and 100 megahertz LTE modulation. It's pretty low. It's roughly 17 milliamps at room temp and varies plus or minus 2 milliamps over temperature.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.